So yesterday we were looking at some algebra related stuff, right? So today we're going to look at more model related stuff. It's not as much of this is going to be where you have to actually do a bunch of algebra, okay? So how about something like this real quick? We've got a model rocket is on the ground. It launches into the air at s equals 0. And if you look at this graph up here, I would encourage everybody in the back to kind of scoot forward, please. That'd be a good thing. I mean, to get where, because some of these are really small and hard to see. This one isn't so much, but some of them are, so get closer. If you look at the graph here, on the vertical axis, we've got height of the rocket, so that's h, somewhere up here. I usually don't label it anywhere. That's the height. The horizontal axis, we've got time, that's s, right? I guess measured in seconds probably. So s equals 0. When we launch it, it's modeled by a quadratic function. So what's the shape of this graph going to be if it's modeled by a quadratic function?
Parabola.
It's going to be a parabola. It's either going to open up or open down, right? It'll be a parabola. It reaches a maximum height of 100 feet and then lands 8 seconds later. Okay, so what we want to do here is we want to plot the points on the grid that represent when the rocket leaves the ground, when it gets to its highest point, and when it returns to the ground. I don't really like the wording on this question very well, but those are the points we're talking about, right? So when time is 0, the height is 0 because it's on the ground. That's when it leaves the ground, right? It gets to some maximum height of 100, and then 8 seconds after it gets to the maximum height of 100, it's back on the ground again, right? So the point here is, because this is a parabola, it's got to have symmetry, right? And we're going to talk some more about symmetry today. There's a lot of questions that relate to the symmetry. Well, that's a pretty good parabola, isn't it?
No, it's pretty nice.
That's not bad. I'm pretty proud of that.
Left side to get the right side wrong.
Oh, come on. There's all one in every graph. So there's my axis of symmetry, right? The axis of symmetry has got to be the vertical line that goes through the vertex. It's got that reflective symmetry about that line. So if this distance right here is 8, it takes 8 seconds to land from when it's at its peak. It must have also taken 8 seconds to get up to the top, right? Everybody see that?
Yeah.
So there's really no math to do here. It's just kind of a graphing thing, right? I'm just taking advantage of the symmetry of a parabola, okay? All right, next question. So something like this now, we really don't cover this in Algebra 2. And that's okay. This is something that we don't really need to cover to be able to do this problem because it's a function. We talk a lot about functions. So sequences and series you do in pre-calculus or college algebra. But we can still do this problem easily. Consider the sequence whose first 5 terms are 3, 9, 27, 81, and 243. Okay? Choose the function with the domain n equals 1, 2, 3, 4, 5. Okay? So those are the values, those are the input values for n. And we want to choose which of these functions, when I input those values, is going to give me these outputs, right? So all we have to do is just see which one works, right? Try some inputs and see which one works. Well, first of all, what happens if we plug 0, or we plug 1 into each of these, right? Because the first input value is 1. So we want to see, when I input a 1, am I getting back 3? Yes or no? So the first one, if I input a 1, I get 3 times 3 to the 0. What's anything to the 0? 1, right? Anything to the 0 is 1. So I get 3 times 1 is 3, so yeah, that one checks out so far, right? So we'll put a check there. Checks out with the first input gives us the correct output. What about this guy here? If I put in n equals 1, I get 3 times 0, that's 0, right? So that one does not work. Already we can take that one off the list, right? It failed. What about this one? If I put in a 1, I get back 3, so that one checks out, right? And then what about that one? If I put in a 1, I get 3 times 1 squared, so that one checks out. So for 1, 3 of them passed and 1 of them failed. But we got to narrow this down to 1, right? So we'll go to the next level. So what if we plug in a 2? Is a 2 going to give us a 9? If I plug in a 2 up here, what do I get? Now let's put this into the function. So for part A, we get f of 2 equals 3 times 3 to the 2 minus 1. Well, what's 2 minus 1? 1. 3 to the 1 is 3. 3 times 3 is what? Okay, so that one works, right? So we get a check. We pass the next test. That one already failed. What about this one? If I plug in 2, I get 3 times 2 is 6, not 9, right? So that one fails. How about this one? If I plug in 2, I get 3 times 2 squared. 12. That fails also, right? So there's our winner. Okay?
Can we just start with 5?
Yeah, you could. I mean, you could, or you could start with, and that's not bad thinking because, you know, if you start with 1, probably a lot of these are set up so they're going to work with 1, right? Because they want to make these difficult, right? Okay, so you might want to start with something other than 1. If we'd started with 2, we would have, all those would have failed and A would have won, right? Okay. So what about this? Very quick questions. These have to do with whether these are functions or not. 3 different parabolas, each defined by a different equation, are shown in the coordinate plane right here. Which graph represents y as a function of x?
B.
B, you're right, how come?
Vertical line test.
Vertical line test, exactly. Both of these are going to fail the vertical line test, aren't they? Right? If I sweep a vertical line across either one of those, it's not going to work. Right? There's my vertical line. If I drag that across, there's a problem, right? Everybody agree that fails? Okay, here's another one. That one's fine, but obviously that one's no good. Okay? So it's got to be graph B. Okay? How about right here? Some students are studying graphs of functions, y equals f of x and other functions. Each table contains some points on a particular graph. Mark whether each set of points might be the graph of a function or cannot be the graph of a function. All we got to do is think about what's our definition of a function, right? No repeating x's, right? So the working definition of a function is for every input there is one output. For every x value there's only one y value. This one, the y's are all the same, but does that matter? No. No. Every x only gives us a single y. There's no repeated x's, and so that one's good. Okay, that one might be a function. How about this one?
No.
Okay, what's the problem with that one?
2 sevens.
Look at that. Input 7, I can output a 4, or I can output a 1, so that cannot be a function. Bottom one? Might be. There's nothing wrong with that one so far, right? For every input, there's only one output, so we're good. Okay, what about this one down here? The equation of any line in the coordinate plane can be written in the form ax plus by equals c, where a, b, and c are real numbers. Choose all of the equations below that define y as a function of x. Okay, one of those doesn't work. Which one doesn't work? 0x is okay, because if I read this one, that goes away, but I still get 3y equals 12, right? So that one's okay. The 0y is the problem, right? Because in this case, I can't define y as a function of x because 0 times y goes away, right? That term goes away, and I end up with the equation negative 3x equals 10. Well, where's my y? I can't define y as a function of x if there's no y, and there's a reason for that. If I solve this for x, look what happens. I get x equals negative 10 thirds, right? What does the graph of x equals negative 10 thirds look like? No. X equals a constant.
No, it's a straight line.
Where is it though?
About there.
3.
Okay, now think about this. If the x values are always the same, it doesn't even tell me what y is. This tells me that no matter what point I pick, the x coordinates are always going to be negative 10 thirds. Straight up and down. It's a vertical line, isn't it? Right? So, yeah, so we know that if I ever have x equals a number, remember, that means a vertical line that cuts through the x-axis at that point. If I have something like, if I solve this one, I just get, oh, that's why I can't see that. If I solve this one, I'd get y equals, because that goes away, right? The x's go away. If I divide by 3, I get y equals 4. What's that look like? Horizontal line. Yeah, the y coordinate is always 4. X could be anything, but the y is always 4. So that goes through the y-axis at 4. So the green line would just look like negative 3 1/3, right? Is where we are, so like right there. That's x equals negative 10/3. The red line would just be a horizontal line right there. Okay, that's not a function because it violates the vertical line test. It is a vertical line, isn't it? Right? So obviously, if it is a vertical line, then it can't be a function because points line up vertically, and that's the whole point of the vertical line test, right? Okay. All right. What about these? So choose the domain for which each function is defined. We'll make this a little bigger. So what are we getting at here? This is stuff that we're kind of just starting to take a glimpse at in the honors class, right? So we haven't gotten to that in our class. And I'm not gonna worry too much about whether, I mean, there's some things we'll not have gotten to, but that's okay. This is still one we can do though, because we know how to think about this problem. We go back to the start of the year, think about what we said about real numbers. There's only 2 rules that we have to be careful about, 2 things we can't do with real numbers. Can't divide by 0, and we can't do what? Take square root of a negative number, right? Okay, so look at these functions up here. There's only the second one and the fourth one, we've got square roots, so we might have to be careful about the square root rule, right? The other functions, function 1 and function 3, well, when we can't divide by 0, are we ever in any danger of dividing by 0 with this third function? No, because what's on the bottom? 6. 6 is not 0. 6 is a constant, it's not changing, right? So there's no red flags on that one at all. There's no variables in the bottom, there's no square roots, and so for that one, there's no value of x that we couldn't use. They're all fair game, right? So that one would be all real numbers, okay? What about the top one now? Is there a value of x that would make the bottom 0? 6. Yeah. So what's the domain of that one? X can't equal 6, right? And here's a way to think about that. If there's my denominator, whatever's in the denominator, if I've got a variable in the denominator, just think about it as being in a bubble. And that whole bubble, whatever's in the bubble, just cannot equal 6. That's what's called an inequation or a non-equation, right? It's where it works exactly like an equal sign. So how would I solve for x there? It should be 0, you're right. Okay, what would I add 6, right? So I get x cannot equal 6. That's my answer. X cannot equal 6. That's the domain. Everything else is fine, but that one value we can't have, right? Okay. How about this guy right here? So if we look at this one, now I've got a variable included underneath the radical, right? So everything underneath the radical there, the 6 minus x, you told me that can't be negative, right? So what could it be? Greater than or equal to 0. It could be 0. Square root of 0 is 0. Or it could be positive. So whatever's inside the radical has to be greater than or equal to 0, right? There's my domain. But I just want to simplify that. I don't want to write it in terms of 6 minus x. I want to know what's the deal with x, right? So if we solve for x, what would I do to solve for x here?
Add it.
I could add it to the other side. That's fine. That's one way to do it. Then I would just get x is less than or equal to 6, and I might want to flip that around, right? That's fine. Or if I wanted to, I could subtract 6 and divide by -1, which would flip that sign. Either way, I'm going to get that result, aren't I? If I start there and I solve for x, solve that inequality for x. So that's my domain, right? So that one makes sense. There it is. Okay, last one. What about this guy? It's a square root again. It's got a variable inside the square root, so we got to be careful. So on this one, we know that whatever's inside which is x plus 6 this time, has to be greater than or equal to 0. So that's pretty easy to solve. What's the one step to get the x by itself? Subtract 6. So I get x is greater than or equal to negative 6. So that goes right there. Right? Make sense? And you could probably, even without doing all the algebra, kind of just reason your way through that one, couldn't you? Like here we would know that 5 would be okay, 4 would be okay, but 7 wouldn't, right? 6 minus 7 would give us a value that's negative in there, and so that's the only domain that deals with that possibility, right? Okay. Here we'd know that any positive number is fine, but if I got a negative number, negative 5 would be okay, but negative 7 would not, right? So that points us to that domain right there. Okay? All right, real quick, while we're on the subject, what about this one? For what values is the given function undefined? Which rule do we have to be careful about here? The square root rule or the divide by 0 rule? Divide by 0 rule. I've got an x in the bottom with a fraction, right? So whatever's in the bottom then, whatever's in the bottom down there cannot equal 0, right? Okay, so what do I do to solve that one? I mean, I could,
Add 4 and then divide.
but I could just add 4 and square root it too, right? So I get x squared does not equal 4, so what does x not equal? 2 or, wait, why don't you up here, buddy? Focus up here.
2 or negative.
Plus or minus 2, right? So plus or minus 2, those are my answers. Okay? Okay? So what about this? This is another one where these they look intimidating because there's lots of g's of x's and all kinds of stuff going on there. It makes you just want to not read it probably. But if you, the thing is, that's the way most people feel about these. And if you just kind of persevere and push through it and read them, what you find is these are usually pretty easy. Okay? So let's talk about this. They don't even tell us what the function is. A function g of x has this domain, right? So x is going to be x goes from negative 20 to 0, okay, including the endpoints. X is greater than or equal to negative 20 and less than or equal to 0. The range is on the interval from negative 15 to positive 15, right? So that's all the inputs and all the outputs of the function have to be in those intervals, okay? Choose each statement that must be false. So let's just go through these one at a time. How about the first one? G of 10 equals 15. Okay, something's wrong with that. What's wrong with it? Yeah, look at that. 10's not in the domain, is it? Right? So right away we can see, yeah, we got a problem there. So, whoops. Not in the domain, right? So that one is false. What about the second one? G of negative 5 equals 13. There's something wrong with that one. It's a little trickier. Can you tell me what it is? Ah, there you go. Look, they told us two values of the function. When I input a negative 5, they tell me that the output is negative 7. When I input a negative 9, they tell me the output is negative 15, right? So they already know that if I input negative 5, it already gives me negative 7. So if I input negative 5, it can't give me 13, right?
Yep.
That would have multiple outputs. So that one is also false. What about C? G of negative 10 equals negative 20. Yeah, the negative 20 is not in the range of outputs, right? So that one's also no good. It's not in the range. And once again, no good. How about G of negative 18 equals 0?
Yeah.
That seems fine, doesn't it?
Yeah.
No problems there. And G of 0 equals 20.
No.
20 is too big. Okay, makes sense? No biggie, can do that stuff.
All false of the answers,
What's that?
so all false questions are the answers.
Yeah, they want to know all the ones that were false on that. Yep. You gotta read them carefully. So what about this? This graph shows the number of music downloads modeled as a function of time. The study begins on day 0 and ends on day 100. So it's telling us, here's the day, here's the number of downloads. We're starting at day 0 and we're ending up here at day 100, okay? So what's true and what's false? The greatest amount of downloads was 180. You gotta read it carefully, because people always, what do you think?
Be careful where you step. I don't want you to step on the tennis ball that I accidentally just dropped over.
Oh, gotcha, okay, thank you.
Anyway, you were stepping back and we were like.
I was so scared.
No, I
Apologize.
dodged a bullet there, I
I
guess.
apologize.
No, you're fine. So the greatest amount of downloads was 180, true or false?
False.
Okay, so on our interval, it really is true, isn't it? Right? Because there's 120, 40, 60, 80. So in this case, it actually does work out that between 0 and 100, that one's true. Okay? Around day 42 was when the least amount of music was downloaded. So day 42, let's see, day 42, there's 10, 20, 30, 40, so that's about right there. And that looks good, doesn't it?
Wait, how is the first one true? Because it's true.
Because at that point right there, isn't that a height of 180? You're thinking about this part up there?
Yeah.
Okay, but it says the study begins on day 0 and ends on day 100. So there, so it ends right there. See what I'm saying? So that part we can ignore. Okay? Around day 42 is when the least amount of music was downloaded. Yep. That's the lowest part of the function. That's the minimum, isn't it?
Yeah.
Okay? How about this? There are 3 intervals where music downloads decreased. Okay, we did a ton of this stuff earlier in the year. A decreasing function means what on the graph? Okay, so in other words, it's going downhill from left to right, right? So if we look at the intervals where it's decreasing, the function is decreasing, it looks like from about there down to there, right? Then it increases, and then there's one more interval right there. Oops, I didn't draw that very well, but you get the idea, right?
Yeah.
Where it decreases again. How many intervals where it decreases? 2, not 3. So that one is false.
That covered.
The amount of downloads increased between days 30 and 50. So let's see, between days 30 and 50, there's day 30, there's day 50. It looks to me like the amount of downloads decreased. It was less on day 50 than it was on day 30, doesn't it? So once again, false. Right?
They really ask these questions?
Yeah, they do. Yeah, I mean, there'll be some harder stuff too, but there's a lot of it that's gonna be like this. Okay, how about this? Joey rides his bike from home. This graph represents the distance he is away from his home in meters as a function of time. All I want you to see here, no big deal, is that it says mark the point on the graph that represents Joey's greatest distance from home. Well, that's just gonna be the peak, isn't it? Right, because distance is on the vertical axis, time's on the horizontal axis. And then it says put a diamond where he returns home. Well, that's where he returns home. No big deal. Okay, what about this one? So these, sometimes people can get confused with the tables because it's not as visual as a graph. But the trick on these is just to think about the table like a graph. Okay, so this table shows the relationship between the height of a golf ball and its horizontal distance from the starting point when it's shot from the ground level into the air, right? So if I were graphing this thing, if I were graphing this relationship, which quantity would I put probably on the horizontal axis? The horizontal distance from the starting point or the height? Height. I would probably put the horizontal distance, right? Because you're going to be probably inputting how far the golf ball's gone down range, and the output is going to be how high is it above the ground, right?
Yeah.
So we've got height and distance. Okay? If I were to do that, now look at the values we got here. So the horizontal distance starts at 0 and it just increases up to 300, right? Make sense? So we're going from 0 up to 300. What does the height do?
Goes from,
Increases.
Starts at 0, it's gonna increase up to, it looks like a maximum value of 185. Okay, can everybody focus up here, please?
It keeps going up.
So it goes up to, it goes up to 24,
Oh.
and then it starts going back down again. I'm looking at the height, which is second row, right? So out there at 150 makes sense. That's where it's at the halfway point. It must be doing something like that, right? Where there's gonna be the peak. See what I'm saying? That's a parabola probably, right?
I don't know.
If we had to guess, it looks an awful lot like a parabola because it's got that symmetry, doesn't it? Right? Okay, so then based on that, do you have to draw the picture? I mean, not really, but on scratch paper you could. At least you want to think of it like a picture, like a graph. So the balls, say it again?
Does that really happen in real life?
Would it be exactly parabolic?
Yeah.
No, it would not.
Yeah, I was gonna say,
It
it's
would.
quite more force.
Well, it's because of the air resistance nonlinear. So
What if there was
it would be.
no-
If you did it on the moon, it would be. But it
Maybe
wouldn't
that's
be,
what
it wouldn't be
they
on
mean.
Earth.
Like,
Yeah, let me just question,
The air resistance would screw it up just a little bit. So the ball's height increased the entire time, true or false? Obviously false, right? The ball reached the ground again at 300 yards from its starting point.
Yeah.
True, right there, right? The height of the ball decreased from a distance of 120. So let's look at this. From 120 meters, the height was 18, to 185. Well, at 185, it's also 18. Okay, so those would be 2 points, kind of like right there and there, right? Did the height change? No, it stayed the same. So that is false, okay?
I gotta get the one right. Yeah, the one wrong.
Yeah,
Just
well,
something fun.
Brent gets
Yeah,
picked
I
on
think
too
it's
much.
like
So what about this? So now we're looking at, okay, so here's another example where you gotta read carefully. Nellie buys batteries in packs of 4 for $6. It turns out in this problem, it never makes any difference that they're in packs of 4. It doesn't make any difference at all, because all we're keeping track of is the number of packs of batteries. So that's extraneous information. Once you read through it, you can kind of just say, okay, you can ignore that part. The shipping cost is $3 regardless of the number of packs bought. Nellie has only $40 to spend. If N is the number of packs of batteries bought, then the cost per battery, C, can be modeled as a function of N. Now, this is starting to sound confusing, right? It's starting to sound like you're gonna have to come up with some function that represents the average cost per battery, but you don't. If you keep pushing on through this. William, stop. Okay, I'm not gonna ask again. You start to think you're gonna have to do something hard, but you don't. It just says, choose the statement that correctly describes the domain of the function. So the set of input values, and that's it, right? That's all they want. They don't want you to find the function, okay? So think about this. What are the values? We have $40 to spend. What are the number of battery packs that we could even buy, right? If we're gonna calculate the average cost per battery pack, like if I only buy one, I'm spending $3 plus $6, it's $9 per pack, right? The average would be $9 and I bought one pack. If I buy two, I'm spending 3 plus 12, so $15 split over 2 would be $7.50 per pack. You see how it's gonna change, right? But how many packs could I even buy with the $40? Because that's gonna limit the domain of my function. N represents the number of battery packs, right? We got $40 to spend. If we want to come up with some function that's going to tell us what the average amount per battery pack is for any number of packs that I buy, I still only have $40 to spend, right? So all I've really got to do here is think, okay, well, let's figure, how would you do if you went to the store, or if you were ordering something on Amazon and it said it's $3 shipping, and each pack is $6, and you only have $40 on your gift card? What would you do? How would you figure out how many you could buy?
well, you subtract the $3.
You subtract the 3, wouldn't you? Exactly. So you'd get 40 minus 3, and that's going to tell you how much money you have out without shipping to buy battery packs. And then what would you do?
Is that amount as your,
You divide by 6, because it's $6 per pack, right? And so that would give us 37 over 6, which is 6 point something.
6 and 1/6, which is like a pretty small number.
6 and 1/6, right? But the point is, How many could you buy?
Six.
Six. You can't buy 6 point something because you buy them in packs, right? So what would your domain be then?
6.
Okay, it's gonna be, so we can immediately cross out, the domain's not gonna go from 1 to 7, okay? But then the other part of this says, the domain is the set of all integers from 1 to 6,
Yes.
or the set of all real numbers?
Integers.
Okay, how come? You're right.
Because you can only buy wholes.
Yeah, okay, you can't buy, what is an integer? Right, think back to our very beginning of the year, we kind of talked about integers all year, just loosely. But integers are just the positive and negative whole numbers, right? The way you think about integers, remember we talked about, on a number line, they're just all the hashes on a number line, positive and negative, right? So integers can't be fractions, they can't be decimals, they can't be square roots, they're just positive and negative whole numbers, right? In this case, that would make sense, because we can't input a partial number of battery packs. You buy them in packs, in discrete units, right? Anytime you're buying something or you're dealing with a function that models something that comes in discrete packets or discrete amounts, that's an integer, right? That's an integer issue. It's a discrete function. It's not a continuous function. And so we would want B. Okay? That's the word we use in math. We call it a discrete function. It only has certain values and nothing in between, right? Okay? Make sense? Okay, along those lines, let's look at these other two. So choose the graph that correctly represents the amount of money Tessa earns. So that's going to be Y is the amount she earns, babysitting for $5 an hour. Well, what's the function that would model that? If Y is how much she makes,
Let me squint real
Y
quick.
equals 5x.
yeah, $5 per hour times X hours, right? Y equals 5X. So that's the function, okay? So we know it's got to have a Y-intercept of 0 and a slope of 5, right? So we can cross some of these out right away.
B.
This guy right here, that's the wrong slope, right? That's the wrong slope also. If we look at these, and you can't see this because it's pretty small, but this goes by 2's on the horizontal axis, on the x-axis, and by 5's on the y-axis. So we want to go over 1 and up 5, or over 2 and up 10. Well, look, that one goes over 2 and up 10, and that one goes over 2 and up 10. But which one would make sense?
C.
C would. How come?
They don't take money from you.
Exactly. They don't take money from you. You're only making positive amounts of money. You can't have a negative. You can't babysit for negative hours either, right?
You can't mess up Tessa. She knows her.
She does. She knows it now. She does. So there we go.
Test is better.
Okay, what about this one? Another one over here, real quick. So this is just a thinking one again. Consider the function f of x equals 25x plus 60. Identify an appropriate domain for the function if the function is used to model each of these following situations, okay? So what about the first one? The total weight f of x of the garbage in a truck that currently has 60 pounds of garbage in it, and each added bag weighs 25 pounds. Okay? So, I mean, that's a weird context, right? But my point,
Her mom, she,
what's that?
I was obviously about like the robot.
No. No, but, so now, is that gonna be, look at your choices. What, hey, put that decimal. Is the domain gonna be an interval of real numbers, or is it gonna be a subset of only integers for this one?
Subset of integers,
It's gotta be integers, you're right, how come?
because you can't have a half the garbage bag.
You can't, right, you're putting in full bags, and each bag weighs 25 pounds. There are no partial bags, right? Each bag they put in is 25. So the weight in the truck is gonna jump from 60 to 85 to 110, it's not gonna ever be in between, right? Okay, so that would definitely be integers, right, because it's a discrete set. How about this one? Total money collected f of x if x people give $25 each and one person gave 60. Is that gonna be integer or real number?
Integer.
Integer, once again, because you're accumulating the money in big increments, aren't you, right? It's not coming in penny by penny, it's coming in big chunks, right? How about this one, the total weight f of x of a wheelbarrow with a weight of 60 pounds that is being filled with sand at 25 pounds per minute after x minutes.
Oh, we need all real numbers.
That would be all integers, wouldn't it? Right? Because it's being filled at a rate of 25 pounds per minute, but you're just pouring sand into the wheelbarrow, and so after 30 seconds, it's got like 12.5 pounds added, right? See what I'm saying? So it's going to be continuously increasing, so that's the one that would be real numbers, okay? Getting the idea?
Oh, yeah.
I just want you to kind of know how to be thinking about these problems when you get to it. So how about this one? This is average rate of change stuff. So during the first 4 years of growth, the height of a tree can be modeled by this function. Height equals negative t squared plus 8t plus 6, where t is the time in years since being planted and h is the height. They want to find the average rate of change in feet per year from year 2 to year 4. Average rate of change, we dealt with that earlier, right, at the beginning of the year. Average rate of change is just going to be change in y over change in x. That's all it is. How much is the output changing divided by how much is the input changing? So we can write that if we want to in its simplest way. Average rate is just equal to y2 minus y1 over x2 minus x1, right? The slope formula really is all it is, okay? Now we have h's instead of y's, and we have t's instead of x's, right? So for us, that's going to be instead, it's going to be h2 minus h1 over t2 minus t1. Well, what is t1 in this problem? 2. It's right there, isn't it? Right? It's the earliest time. It's the first time. What's t2? 4, right? Time increases from a starting value of 2 to an ending value of 4. So then if we want to calculate the h's, h1 is just going to equal whatever we get when we plug t1 into the function, right? So it's going to equal negative 2 squared plus 8 times 2 plus 6, which is, what is that?
18.
18? Okay. You sure?
Kind of.
16? No, I think you're right. 22 minus 4, you're right. 18. Okay, what about H2? H2 is what I'm going to get, so we plug that in there. H2 is what I'm going to get when I plug T2 into the function. So I'm just going to get negative 4 squared plus 8 times 4 plus 6, and what is that, 22? Okay. So now all I have to do is plug those numbers in, and I'm done, right? So average rate just equals 4. I'm going to get 4. No, sorry, I'm going to get 22 minus 18, right? Divided by 4 minus 2. So that gives me, what, 4 over 2 is 2? Everybody got it? Okay, you guys knock it off. Okay, 2 feet per year. What about this one? The height of a tide on a dock in feet is modeled as a function of time. They want to know what's the average rate of change between hour 4 and hour 8. Well, we did this stuff, right? That's just going to be hour 4. That represents the height of the tide at hour 4. That represents the height of the tide at hour 8. So all I got to do is make a slope triangle, right? What's my rise and what's my run? So the rise,
It's about 44.
it looks like it's going from about, let's just round this off. Let's say it's going from, that's 2, 4, 6, 8, that would be 10. So it's going to be 10 minus about 9, just roughly, right? It rises by 1. My run, well, the run is going to be 4, isn't it? From 4 to 8. So the slope, which is the rate, is just going to be 1/4, or 0.25, right? Okay, and they take anything from 0.2 to 0.3, so it's fine. Okay, they give you a little wiggle room in there, right? Okay, last one. What about this? Alex records the number of minutes M it takes him to draw a picture in a table. Okay, so after one drawing takes 28 minutes, 2 drawings takes 58, 3 takes 85. Choose the average amount of time it takes Alex to draw the first 3 pictures. This is a very simple problem. What do you do?
Add them all.
Please excuse the interruption. I have
Nope,
a bus
you don't even have to do that.
announcement,
You don't have to do that. This is cumulative, right? This is a function. If I input 3 drawings, the output is 85 minutes, right? So if it takes me 85 minutes to draw 3 drawings, then isn't the answer just 85 minutes divided by 3 drawings? And what does that work out to be?
35.
It's
Not 35.
It's about, that's gonna go into that, let's see, 2 with 2 left over, so 28 and a third.
So 28.
So if we round to the nearest picture, we get 28. You get the idea?
Yes.
Yeah.
Okay, good work. A lot of stuff.
Are we going to